Very good morning, my dear students. Last class, in electricity lesson, we have completed up to the electrical components. Today, let me discuss about electric potential and potential difference. You are now very familiar with the water current and air current is nothing but water current and air current. What it says, water flow will be there in high pressure to low pressure. At the same time, air current also, that is air flow also will be there in high pressure to low pressure. So you also know that there must be a difference in temperature between 2 points in a solid for the heat to flow in it. For heat flow also we need a difference. High to low difference must be, then only the flow of heat also will be there, which we discussed in the last lesson itself. Similarly, a difference in electric potential is needed for the flow of electric charges in a conductor. In the conductor, the charges will flow from a point in it which is at a high electric potential at a point which is at a lower electric potential. Electric potential. So listen the definition, students. Electric potential. The electric potential at a point is defined as the amount of work done in a moving a unit positive charge from infinity to that point against the electric force. Listen me carefully, students. Making the positive charge move from one point to the infinity distance. For that, how much work was given? That is called potential difference or else electric potential difference. Listen me once again. The electric potential difference between 2 points is defined as the amount of work done in a moving a unit positive charge from one point to another point against the electric force. We can consider the 2 point. Suppose you have moved a charge Q from a point A to another point B. For example, we can consider a point from A. We can consider the point from A. This end we can consider as A and this end we can consider as B. Listen me carefully, students. Suppose you have moved a charge Q. Charge is denoted by the symbol Q from a point A to another point B. So what is the work done here? W we can be considered as the work done. So here W we can consider as work done to move the charge A to B. So what is the work done here? We move the charge from A to B. For that, what is the work done here? W. Then the potential difference between the points A and B is given by the formula. Look at the formula here. V is equal to W divided by Q. So look at the diagram here. What we are doing here, we are making the positive charge to move one place to another place. That again we can consider the point A to B. And then, so for that, what's the formula here we are getting? Potential difference is denoted by the symbol V. Work done is denoted by the symbol W. Amount of charge which we moved from one point to another point. Here I told you A to B. That is amount of charge is denoted by the symbol Q. So finally, what is the formula here? We have a V is equal to W by Q. So this is the formula for the potential difference. Now, so what are the units we have? Let me discuss the SI unit of electric potential. Electric potential or else potential difference, both are same. SI unit of electric potential is volt. What is that? SI unit of electric potential is volt. The potential difference between 2 points is 1 volt. If 1 joule of work done is done in moving 1 coulomb of charge from one point to another against the electric force. Now, what is the unit for the work done? Work done unit is nothing but joule. 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 And charge unit is nothing but, charge unit is already we know well, that is coulomb. Okay, students, coulomb. And so next, let me discuss about Ohm's law. I hope you all understood about what is that potential difference and the units also. And let me discuss about Ohm's law. Ohm's law is relating the three factors such as, Ohm's law is relating only the two factors, which is potential difference and then the current. And then R is nothing but is a constant, okay? R is nothing but constant. Look at the first formula, students. Ohm's law at a constant temperature, the steady current I flowing through a conductor is directly proportional to the potential difference V between the two conductors. So what I said, that is potential difference is directly proportional to the current. Potential difference is directly proportional to the current. And so with the proportional term, we have to remove the proportional term into equal, so that we are replacing the constant term, which is nothing but R. R is a constant term. R is nothing but resistance. So this is the formula here we have. V is equal to IR. But we can modify the formula in whatever the factors we need. For example, if we want I, we can change the formula into I is equal to V by R. And R also we can, if you want resistance value, we can modify the formula as R is equal to V by I. I hope you all understood, students. So what is the formula? V is equal to IR is nothing but Ohm's law. Here R is a constant for a given material. So we can take any material, that is nichrome is one of the metal at a given temperature and is known as the resistance of the material. Example for the resistance we can consider as nichrome. Nichrome is one of the metal. So first of all, let me discuss about, and before that you should know what is that resistance. Am I right, students? Resistance is nothing but, resistance of a material is its property to oppose the flow of charges. Oppose the flow of charges, and hence the passage of current through it is different for different materials. Listen the diagram, students. Actually, there is a current flow with a wire and there is a zigzag path. When the current comes to the zigzag path, there is a flow of current will be reduced somewhat because there is a resistance. Okay. So, resistance of a material is its property to oppose the flow of charges and hence the passage of current through it. It is different for different materials. I told you nichrome. Nichrome is one of the example for the resistance, and resistance value will be different for different material. So what's the formula here? R is equal to V by I for V by I. R is nothing but V. R is equal to V by I. V is nothing but voltage and I is nothing but current. So the resistance of a conductor can be defined as the ratio between the potential difference across the ends of the conductor and the current flowing through it. So look at the first formula, that is the formula for the resistance. R is equal to V by I. And so what is the relationship between the current to the resistance? Current versus resistance. Actually, so already we have discussed, look at the first formula, R is equal to V by I. That is, I and R is inversely proportional, students, inversely proportional. So once the R value is getting decreased, current value will be increased because both the factors were opposite to each other. And if you increase the resistance, there will be the decreasing of the current because both the current and resistance are opposite factor. Okay, so what is a unit of resistance? Unit of resistance, R unit is nothing but ohm. What is it? R unit is nothing but ohm. This is a symbol for the ohm, or else we can write by the letter OHM. Okay, OHM is the unit of resistance. Unit of resistance. And then, so this is what are the factors where affect the resistance. Length will be affected, and then thickness and temperature will be affected. According to the length, according to the thickness and temperature, a resistance factor will be affected. And temperature, I told you now only, the resistance of a metallic conductor increases as the temperature increases. Example, copper. The resistance of a semiconductor or else insulator decreases as the temperature increases. This is for the semiconductor, and the first one for the good conductor. Okay, students. And here some factors are given for resistivity. Resistivity is different from resistance. About resistivity, we will discuss in the next class. I hope you are all understood, students. So in this lesson, whatever we have discussed about the resistance is nothing but it opposes the flow of charges in the conductor. Okay, it opposes the flow of charges in the conductor, which is R is equal to V by I. And then Ohm's law we have discussed. Ohm's law is nothing but voltage is directly proportional to the current. And then when we remove the proportional term, R can be replaced. R is nothing but resistance. And then we have discussed about the electric potential, that is V is equal to W by Q. So I hope you are all understood, students. And then unit also we have discussed. A resistance unit is nothing but a ohm. A voltage unit is nothing but volt. I unit is already we have discussed. Current unit is nothing but ampere. I hope you are all understood, students. Thank you.